Okay, we're going to try to stay on time here. I'd like to welcome Axel Rosenberg from one of our precious gold sponsors, Weka, to present performance as the profit driver in AI. Axel.
Should I start?
Yeah.
Okay. Okay. Can you hear me well? It's a lazy afternoon. Maybe some people are already tired. Some people will come in. So let me get started. There was already a lot of interesting sessions this morning about democratizing AI and models. I talk somehow about models, and there were just accidentally discussions about memory as a cost driver and the shortage of hardware. And I think Fasile, you were came all the way from Australia to here. Were interesting how multi-protocol parallel file system architecture can help you to re-architecture your AI infrastructure and to build a memory grid. We called it augmented memory grid. So the title is The Token Economy as the industry. When I say industry, it's not the commercial, the enterprise industry. It's also the industry of doing AI, of doing HPC, also including academia. And we all have new challenges. So to reflect it as the industry evolves, so let me go back 35 years something, when the area of internet started. Then after this, the virtualization area was there. People always tried to make things more efficient. And then when Weka was born, it was around about 2012 to 14 when it was the cloud area. And then three things happened at the same time. First thing is containerization, which helped you to isolate workloads, which helped you to build software-defined architectures. At the same time, where high-speed and high-bandwidth networks were common. So it started with 100 gigabit. Today we are at 400 gigabit. Before we had that network infrastructure, you had to look for your data as local, data locality, because the network was the bottleneck. Today, the CPUs are the bottleneck. With 400 gigabit infrastructure fabrics, the network is no longer bottlenecking at you. This has implication on how you architect, particular metadata services. With Weka, you don't need dedicated metadata service, so we share everything across everything. And underneath what you see here is what we say the majority of AI users, the early adopters, and it really dramatically changed the past 12, 15 months, where inference became the dominant driver in building architectures. This is not just only in the neo-clouds, so the GPU as the service providers, but this is also, I see it in academia, and the colleagues of CSCS are facing the same problems. From a Weka perspective, we have one software, but we have different approaches to deploy, to architect the software. So the traditional HPC-like, using Weka as a multi-protocol parallel file system. You can use it in pre-built appliances. Our early adopters, they had not only 4 to 8 GPUs, they were already going into the tens and into the hundreds. And if you do, it was all about pipelining, machine learning pipelining, building it. It was about reducing the epoch time. So it was about latency and IOPS. But today, it's about a memory limitation, because it's not only because the prices raised so high the last 6 to 8 months, and even we have shortages about it. It's about the architecture to keep your GPUs busy and how to accelerate your entire inferencing processes. This is what I want to talk about with you. And the entire AI journey, we divided it in 5 blocks, and the more colorful blocks are where Weka really shines. So this does not mean that we don't bring you value even for AI training, but the data preparation, this is still where 60 to 80% of the most time is spent, and enterprises, they take more than a year, up to 1.5 years, to actually build the pipelines. So data preparation is where the journey begins. So where's the first dominator where Weka can shine. In inferencing, we are a huge benefit. And the future has already started today if we go to data services and insights. And there's a lot of driven joint working together with NVIDIA. They have these projects AIDP, where we have added accelerators to the storage and to make vector databases more taking insights out of your unstructured data. Looking at this, let's say, from a perspective of verticals. So most people here, I think, are working in research, meaning the public sector, in academia, and there was HPC, but the inferencing is growing also in academia. And that was the nice presentation about the open source models, which I hope will really be challenging the commercial models from various aspects. And AI training, AI inferencing, that's what the vast majority of our current customers, the project we won the past 12 to 18 months only, where are they dominant? So again, from our architecture perspective, so what you see here is a neural mesh hybrid flash appliance. So that's the core foundation of our software. We have, by the way, that's only one software, but there's different approaches how to roll they out and how to make the most benefit out of it. In training, the neural mesh axon, from a traditional perspective, you could also say this is kind of converged infrastructure. And here comes the point. We recently had a customer, a medical research institute in the United States, and they identified 1.5 petabytes unused TLC NVMe in their systems, in their local systems, supposed to use them as local scratch storage, but this is no longer fitting into the architecture. So how if you have something to use the already existing but unused NVMe in a capacity of 1.5 petabytes. That would be a huge win. So the Axon, what does it is? Imagine an 8-way GPU server where you have 1 or 2 NVMe and most of them ship pre-built with them. And you build your parallel file system across hundreds and thousands of nodes without additional external storages. So this has one advantage. You have not to buy servers because they are already in your system. Your GPU systems, they have 128 or 256 core CPUs, so you could spend some of these cores to manage the storage infrastructure. And the most important thing is you can use the East-West network. So the East-West network, which is used by the GPU with NVLink, etc., you can use it for the storage traffic and not the higher latency north-south network. This means you can build already a mesh or a memory grid, which is then the next point. A memory grid is, from a memory level perspective, you have HBM, which is limited and the most expensive one, then you have DRAM, and then you have persistent, but NAND, NVMe, has a way higher latency. But as the data is processed local in the GPUs, in the HBM, and the time the data resists in your local memory, you have to reload it, you have to pre-fill it, all about. And all these are context switches and adding latency. With an augmented memory grid, the data is visible to shared to all of your thousands of the GPUs. So you have not to load it all by the time. And the bigger your model is, we can keep up, and this is what I show in a couple of graphs soon, and also with some customer statements, that our augmented memory grid has a lower latency than the HBM when you do inferencing. Before I go there, let's just imagine what is the cost of your entire architecture. The blue bars, which you see here, this is the cost of the memory of the HBM, of the GPUs, the DRAM, and the actual NVMe. And when it started with the A100 systems, it was below 50%. Meanwhile, with the GB300 systems, we are, what is it, about 63%. What if you could reduce this cost by two approaches? One approach is what I already mentioned, use the NVMe, which you have already in your GPU systems, or orchestrate the persistent file system layer, not just using RDMA semantics and file semantics and GPU direct storage, but build a memory grid and build therefore a token warehouse. That's the idea showing this graph. From an NVIDIA perspective, you frame the relevant storage architecture, for example, behind VLLM or Dynamo. And what you see here in the host memory, we have benchmarks and we have actual customer data so that we outperform it by a factor of 20 using our augmented memory grid compared to host memory. So this is data from a customer, Cohere, running in the CoreWeave cloud, and I have some customer statements at the very end. What you see here is two things. One thing is the latency, the time to the first token, and the token throughput. The bars where you see the lower is the better, which means the time of latency. And you see the purple one, which is the Weka from the Weka file system. The blue one is the HBM, and the light green one is the DRAM. You see on the left side even more significant than on the right side, but this is caused to the different architecture of the models. That DRAM really sucks. Yeah? So we so easily can outperform DRAM with an augmented memory grid. And we keep even in a model then like Qwen 3, which is a mixture of expert model, where not always the entire model is loaded into the GPU, where parts are loaded, where you have more and more pre-fill runs. We still keep with a number of concurrency, so this is real customer hard, real-world examples with multiple processes running at the same time. So we can keep up both the latency and the bandwidth compared to HBM and to DRAM if we build an augmented memory infrastructure grid for inferencing. I forgot to ask some questions, but it's still time. Maybe before I go to the next subject. So when I was here 4 years back, I think it was 4 years, I was talking to a gentleman from EPFL, and we were joking about how AI influences the work of a real coder. And he said, from time to time, he's using AI to review his code. And he did not really feel comfortable with this because 4 years back, could you trust it? Would you look as a lazy person? Why do you use AI for a review? So let me ask here into the group, who is today using tools like Codex or Claude in the daily work? Please raise your hand. Yeah, it's just a few. And you do it not just privately for fun, so it's part really of your structured work, right? Yeah. So in only 4 years. And let me ask you, are you doing this since less than 12 months? Yeah. And you're doing it more and more? And you're surprised by the results? Yeah. And this means the organization we are working in is paying for it. So you have a subscription with these guys. Do you control the cost per individual, or was there any guidance? So it's hard now to give me the answers, but just say no or yes. Yeah, so it's expensive, right? We are using it in my company in both regions, so our R&D is using it just to build a model and to give some ideas and then to work from them and make it real. They used it in QA, also for the same reason, like the gentleman from EPFL started 4 years back. And we, in sales and marketing, we use it for doing customer researches, for doing weekly reports, etc. And then it's really interesting what Claude is doing, but also the mistakes they are all doing. Yeah, so we have to be really careful. But I think this is something which no one will roll back, right? So it will be part of your daily work to use these tools. And when it comes to agentic AI, it is get even more complicated. And you know also, you build a prompt, and then the system is working on some time, and this is, it's using memory. Yeah? You are not paying only for thinking, that would be great, it helps you thinking, but you pay also for the cache hit. And this is the actual matter I want to talk this afternoon, and I would be happy if something remains with you and you can think about for the future how to build your infrastructure. So this is 5 metrics which matter. I think the input, of course, and the time to first token, and let's say the number 3, it's a result of function 1 and 2, and the actual driver is the cost per token you have to pay, but this also relates to the context window. So the context window is limited in every step you are going in such a project before a new prompt generates a new context and you have new output tokens. So input, cached input, and output. From a commercial perspective, input, this is your capital, this is your investment, or this is your invested capital. The output is the result, this is the product which you build. So how can you control the cost, and where is the most relevant area to optimize the process? And we think it's with the cached input. Not only that the providers like Anthropic or OpenAI, they give you some discounts, the more cache hit rates you have. So we build an average of 75%. With Anthropic, it goes up to 90%. And this is what I meant when you're doing it interactively between prompt and prompt. Humans, they are lazy. If you not answer on time, you have a wasted memory cost. When it comes to agentic AI, you have multiple agents running at the same time. And anytime you have to load your Kiwi cache again, it's additional cost. And with the example we have a good idea or in which ratio it would help you to reduce the entire cost. And I would say in average it's about 75%. I think the slides will be shared afterwards and have all the sources of what I have here. I see it right now in my speaker notes. So this is all public available information. The next slide, now it becomes really colorful. So this is about how crazy it can be if agents and KV cache is running your system, and KV cache is really the way how you can control the cost. And this is also, there is a URL at the end, but I will also show a QR code. This is from a blog from our product manager of the AMG, and he has way more details on data where he compared it with different models like R1, like QVen, like LLama, and multiple others, and also some open source models. So why is that important? Because it shows the problem becomes even bigger once you work with agents. So the flat bar, what you see, what's almost static below, that is your cache hit. So, and each tooth shows you one process until you need to have an orchestrator to compress the data and to limit that everything runs out of the context window. The orchestrator is point of architecture, but the orchestrator is also your switch to control the cost. So the fancy colors on top, these are freshly generated input, and this is the output tokens, is the small pink dots always there on the bar. And really crazy, it comes when you go to testing, where you have a lot of interaction, and here it saves you time. The more you can consume from the cache hit you have already there, the faster you can start with the next from, and it is really, it helps you to control the cost. A practical example, as we have so many colors here, I think is, imagine each of these circles is you want to paint a car. So you mix 50 liters of paint, you paint your car, the car is ready, you throw away the paint, and then you have to paint the next car. You again mix 50 liters of the paint. So you always start from scratch, and you do not reuse what you left over. And increasing the cash hit rate is keeping the economics and making the processes faster. So with the architecture I tried to explain in the beginning, even from a NVMe persistent NAND file system, you have in the accommodation of the capacity, you have a lower latency than loading it again into HVM and start from scratch. That is what that slide should demonstrate. And now I face in the QR code. You can take a picture of it, and this guides you direct to the blog. Otherwise, you can also see the URL at the end. This brings me now to another example where you see it's really black and white, how dramatic you can save the costs. This is from a token pricing example from last year in October with DeepSeek. What you see on the left side with the spike through, this is just the previous price. So even if the model provider is reducing the price, you see what you have to pay for a cache hit and for a cache miss. So it's factor 10. And it could be with one is factor 12, and with the other ones it could be factor 8, or it can be even go higher. And another metric is it's about €8 you have to spend for 1 million of tokens. And if you're using it in your daily work, applications like Codex or Claude, which is used by the public agency. I had a discussion with the German public agency recently. They have 20,000 active AI users, and each of the users is producing over the day 300,000 tokens. And then you can see what the money is about at the end of the year, just from a perspective if you can reduce this. And coming back to the title of the presentation, token economy, performance is a profit driver. Performance in terms of latency, time to first token is not just in a single process, but with agentic AI, it accumulates to a huge number. So I mentioned it earlier from a Weka portfolio perspective. You can read this from the top to the down and from the left to the right. So neural mesh, which is a traditional parallel file system. It scales limitless, it has multi-protocol storage, and beyond our OEM partners, we have also the Weka pod, which is a pre-built appliances, which can be sourced via the distribution. Then the augmented memory grid, I did not mention. Augmented memory grid actually is an API which presents the file system as a persistent memory extension. That's just an API, it's open source, it's not an extra product cost, you can use it for your existing Weka environments. And now the journey continues to the AI extensions driven with NVIDIA AI DP, and the first CMX developments together with NVIDIA are also underway, and that's the product portfolio. Now coming to the customer quote, who had been happy to use one of our early adapters of augmented memory grid. And they reuse the inference deployments from 5 minutes to 15 seconds. On the other time, and they had a 10 times faster checkpointing, which is just another approach of the powerful distributed architecture we have. I think with this, I was quite good in time. We have 4 minutes left for questions. I would be happy if there are some questions.
Thank you. Thank you, Axel.